Good morning, students. This is your science teacher, Neelam Elawat. And today, we'll continue the topic which we had started in the first video, that is the refraction of light. This is in addition to the first part, so this is your part number 2. So be ready with your notebooks and pen, and let's start with the topic, that is refraction. Now, if you remember, students, in the first video we have talked about that refraction. In case of refraction, we always have two medium. Okay? We always have how many medium? Two medium. And what are the name of those two media? Very true. One medium is a rarer medium, and second is your denser medium. So in case of refraction, we'll always have two medium, medium 1 and medium 2. This could be, and these two medium could be rarer and denser. Any one medium could be rarer, any one medium could be denser. Now what is a rarer medium? The medium in which speed of light is more. And denser? The medium in which speed of light is less. Very good. So we have two medium, medium 1 and medium 2. Okay. Now this is your line of interface. Above it you have medium 1, below it you will have medium 2. Okay. So this point O is a point of interface. What do we call this point O? Point of interface. Okay, this point O is called point of interface. And this line is called the normal ray. Normal ray means a ray which is drawn perpendicular to the surface. Right? So this is your normal ray. And normal ray is drawn at an angle of 90 degree. Right. Now this is your incident ray. Okay, this is your incident ray. Now incident ray is making an angle with the normal ray. What do you call that angle? Tell me what you call that angle. Now this ray is your incident ray, this ray is your normal ray, and when the angle between these two rays is called angle I. And what is angle I? The angle of incidence. What do you call this angle? Angle of incidence. And where is the angle of incidence? It is always between the incident ray and the normal ray. Angle of incidence is always between incident ray and the normal ray. Very good. And this point is your point of interface. This is the point where your incident ray will enter into the second medium. Okay? Do you remember? We have seen the bending of the pencil. Remember that photo? Yes. So at this point, the speed of light, you can say the incident ray will enter into the another medium. Okay? Now, as the light enters from one medium or it goes from one medium to another, its speed will either increase or decrease, isn't it? Its speed will either increase or decrease. Let's take this medium as a rarer medium. The medium 1 is your rarer medium. Okay, so medium 1 is your rarer medium. And medium 2 is your denser medium. So in rarer medium, the speed of light will be more. Yes? And in denser medium, the speed of light will be less. Very good. So incident ray, when it enters into the into the denser medium. It is entering from rarer to denser medium. Okay, it is entering the rarer to denser medium, right? So it is entering from rarer into denser medium. What will happen? The speed of light will decrease. The speed of light will decrease, right? If here the speed is v1 and here the speed is v2, so v1 will be more than v2, right? Yes or no? Right. The speed of light is more in rarer medium, speed of light is less in denser medium, and when it goes from rarer to denser medium, its speed will decrease. Okay, its speed will decrease. Okay, so this angle R at this point, which is called the point of interface, the speed of light will go from rarer medium to the denser medium. Okay, and since it is going from rarer to denser medium, it will bend towards the normal, right? It will bend towards the normal. It was supposed to go in this way. It was to go in this way, right? But it is going in this way. Right? This would have been the angle R. अगर लाइट इस तरीके से जाती तो आपका एंगल आर ये होना था, लेकिन लाइट ऐसे नहीं जा रही है, राइट? लाइट ऐसे नहीं जा रही है, सो आपका एंगल आर जो है वो कम हो गया है, राइट? आपका एंगल आर कम हो गया है, जितना होना चाहिए था उतना नहीं है, जितना होना चाहिए था उतना नहीं है. आई होप आई एम क्लियर. एंगल आर ये होना चाहिए था बट ये नहीं है. अब एंगल आर सिर्फ ये है, दिस पोर्शन, ओनली दिस मच पोर्शन. आई होप आई एम क्लियर एवरीवन. यस, सो दिस पोर्शन. So angle R is less than angle I. Now by the way, what is angle R? Angle R is called angle of refraction. What do you call it as? Angle of refraction. An angle of refraction is always between the normal ray and the refracted ray. This ray is called the refracted ray. This ray is called refracted ray. This which ray? This ray. This ray is called refracted ray. Okay. So incident ray, the angle between the incident ray and normal ray is called angle of incidence. The angle between the normal ray and the refracted ray is called angle of refraction. Okay. So I am repeating the point. Light always travel from one medium to another. In case of refraction, light will travel from one medium to another. Second, when light goes from rarer to denser medium, its speed will decrease. Okay, its speed will decrease, and the angle of R will be less than angle I. This is your point number 2. Angle I is less than angle R. Okay, have you understood? Okay, where is angle I? Angle I is between incident ray and the normal ray, and angle of refraction is between the normal ray and the refracted ray. Okay, So we have to use these things only: incident ray, normal ray, and reflected ray. Normal ray, incident ray, they all lie at the same plane at this point. This point is called point of interface. This is your law number 1. And second law is this angle I and this angle R, the ratio of these two angles will always be constant. Okay, the ratio of these two angles will always be constant. Have you understood, everyone? Very good. Now let's see the two laws. The first law says the incident ray, refracted ray, and the normal ray, they lie on the same plane. They lie on the same plane. The second law says the ratio of sine of angle of incidence to the angle of refraction is a constant one. Means you can write sine I upon sine R is equal to constant. Right? So angle sine I upon sine R is equal to constant. This is your law number 2. And this law is also called as Snell's law. This law is also called as Snell's law. Are we clear with this? Yes. So we have two laws of refraction. One is the incident ray, refracted ray, normal ray all lie on the same plane. Second is called the Snell's law. That is the ratio of sine I upon sine R is equal to constant. And this constant is called the refractive index. This constant is called the refractive index. What we call this? The refractive index. Clear, everyone? This is called refractive index. Are we clear with the laws of refraction? Very good. So let's come to your homework now. You will make notes of this topic, that is the laws of refraction. Second, you will read the page number 174 and underline these laws of refraction in your book. Okay? Very good. And you will send a photo of your homework done to me on my personal number, right? Very good. Well done, students. And bye. Enjoy your work.